Hey guys, this is the video for the week of October 24th of 2024. The methods I'm going to be using are a mix of methods that work for me or methods that you guys have used in class. Again, use whatever method works for you. If you found a method that works and you're getting the right answer, just go ahead using that. But yeah, so for number one, they're wanting for these are going to be simplifying. We started with 216, and I wanted to already simplify that into its prime factorization. I did that over here, as you can see, and we see that there are these 2s and 3s. That is the smallest that they can get to. So we can kind of simplify that 216 into 2 times 2 times 2 times 3 times 3 times 3 times, and if you remember, you can split this up from that property that we learned, so that still equals the same thing as that, right? So our next step here is, if we remember, we find the groups of 3 and we pull those numbers out. So this is going to be pulling out to 2 times pulling out of 3. And we haven't touched this one yet. This is what leaves with the 15, x to the 15th, under the cube root. From this, we can simplify that 2 times 3 to 6. And this can be kind of turned into x to the 15th to the 3rd. That's the same thing as cube root, right? That can be simplified into 5, or 15 over 3. So 6 times x to 15 over 3 is just 5, right? So this is what we can simplify that to. All right, for number 2, we are wanting to simplify again. I did it over here, the prime factorization, and what you want to see, you need 4 of something, and you see there are 4 2s that this can get to. So when simplifying that, you put it under the radical, right? The 2 times 2 times 2 times 2. And again, I'm splitting them up for my sake. It makes it easier to kind of worry about one than the other. So for this one, remember, we find the groups of 4. We pull it out, so it's no longer under the radical. And this can be simplified, or turned into, right, the 28 to the 4th. That's the same thing. That can be simplified into 2 times x to the 28 over 4. And that can be simplified to 2 times x to the 7th. So that is what you should be getting simplified there. Our next one is 81, and it's just a square root. So we find 2, and over here you saw that I used the factor tree, and you can see it as 9. So again, we are splitting it up just so it's less confusing. With x to the 12th, right? And we found that group of 2, or the pair of 2, 9, here in the radical. This can be turned to something more simple of 12 to the half. That can be simplified, right, to x over 12 over 2. And you could do x to the 6th. So that's those methods. Another ones you guys were using was you really list out. So you could list all of the 12 x's and then find the groups of 2. I just see that as you're finding groups of something, you're dividing it by that number. That's kind of how I was seeing that. Again, you can always ask me other ways to do it. This is just the way it works with me. First, the simplified square root of 9. You can do a factor tree, or you sometimes have that memorized. It's just 3. For number 5, so I showed this method in class, but the way I split this up, again, if you remember, this is the same as, so you're wanting to divide 56 by 7, right, from here. So a way to do that is you can split these numbers up. You can split those numbers up, or you can just do 56 over 7. right, is 8. And so you can see that you're not splitting it up for 5, sorry. And then number 6 is where you are splitting it up, right? Because you're doing x to the 70th to the 1/9 power, which you're doing 70 over 9, which again, you can see those are not going to go in evenly. So a method you can do is we are going to split that x to the 70 also equals x to the 63rd times x to the 7th. So that all equals the same. But now, when we take this to the 9th, right? That's 63 over 9. That's an easy 7 pulled out of there, right? So we have a 7 pulled out, but we still have that x to the 7th under there because 7 doesn't divide 9. So that 9 still stays in there. And that is kind of how you see on number 6 how D is the answer there. But yeah, a method of doing that is to split it up, or you could list all 70 x's and find groups of 9 and see there are 7 groups of 9 x's and 7 x's left over under the radical. Again, so these, you can find your own method. I highly recommend finding your own method. Don't use someone's method if it does not make sense to you, because you will just be lost on what you're trying to do. For number 7, this is kind of an easy notice here. You do x to the 6th to the 6th. So I'm seeing that as x 6 over 6 equals x to the 1. Again, I'm going to just show the method here just so you guys can see it. This, you could see it as this, where you list all 6 x's and you find that group of 6 and you have that 1, right, the 1x, and that's what you're left with. So this and these two equal the same. So that's just another method for number 7. Now for number 8, this is another split up method, because you're going to see when you're doing x to the 46th to the 1/7, 46 does not divide evenly with 7. However, the closest multiple of 7 to 46 is 42, right? So x to the 42 times x to the 6th, that equals the same as x to the 46. And you can always fact check that. But now when you're taking it to the 7th, you can take these to the 7th each. And you should be able to see that 42 over 7, that's 6, right? So you have an x to the 6th times x to the 6/7, which you're going to know, you remember that formula where that is the same as x to the 6th under the 7th. Or, yeah, the 7th root. So from that, we have x to the 6th with x to the 6th still under that radical. Or, not x to the 6th. I'm so sorry. Let me take that back. That's actually a 4. So yeah, definitely check that math when you're doing that. It's x to the 4th, not... Yeah, that makes it a little less confusing. Sorry about that. Which you're going to see what I circle on there. So there we go. That makes more sense. And that is where we see the answer of A. Alright, in the next video, we will work on the rest of the problems. I'm going to split these up. Again, if you have any questions, you can always email me.